On to 4.2 now, talking about mass in the imperial system. The mass of an object refers to the quantity of matter in it, and it remains constant no matter where the object's located. So that means whether we're here on Earth or on the Moon or another planet, our mass is always the same. The weight, however, changes. Weight of an object is a measure of the force of gravity on the object. So if gravity changes, so does the weight. So actually, on the Moon, you're lighter. On a big planet like, if you could touch down on Jupiter, then you'd be a lot heavier. Now on Earth, the mass and the weight of an object are essentially the same thing, because when we talk about the mass, we talk about so many kilograms, and that's basically what we use as weight. When we get, if you do physics 11, for example, we'll talk about weight with a slightly different unit. We'll talk about newtons for weight, because weight is actually a force. So we're going to talk about mainly talking about mass, and we're using kilograms and perhaps pounds and other forms or other units to do with mass. Basic units of weight in the imperial system. Now here they are using weight again when we really mean mass. So mass and weight will be interchangeable in this unit. We use tons, pounds, and ounces. Notice that they're giving you a conversion factor here. That 1 ton is 2,000 pounds. So remember that. You'll need to use it. And 1 pound is equivalent to 16 ounces. Okay, example 1 is saying that Manuela needs 1 pound 2 ounces of Gruyere cheese, 12 ounces of cheddar cheese, and 11 ounces of Swiss cheese for a fondue recipe. Well, how many pounds of cheese in total does she need in all? Well, let's look. Let's add them together first of all. Well, first cheese was 1 pound 2 ounces, then the next one was 12, next one was 11, so if we add that up, it's 1 pound 25 ounces. Remember that 1 pound here is 16 ounces. So we can take this 25 ounces here and change some of this into pounds. 16 ounces of this can be removed and changed to 1 pound. So that's what they did here. The 25 ounces is really 16 plus 9, or 1 pound plus 9 ounces. Okay, now if the 25 ounces is 1 pound 9 plus the other pound, she now has 2 pound 9 ounces. Okay, so the 1 pound plus the 25 ounces was really 1 pound 9 ounces, gives us the 2 pound 9 ounces. So that's what she needs for her recipe. Of course, another way to look at it is you can change the whole thing into ounces. And they're giving an alternative solution here. First of all, change the 1 pound 2 ounces into complete ounces. So that's 16 for the pound, plus the 2 gives us 18. Add all the weights together, and we have 41 ounces. If we wish, we can change this now into pounds. We can divide this by 16. Or if you're doing unit analysis, of course you will take the 41 ounces and multiply it by 1 pound for every 16 ounces. These ounces cancel, giving 41 over 16 divided by 16. This will give us 2 and 9/16, or 2 pounds 9 ounces. So we have another alternative solution. Again, basically by looking at the 1 pound 2 ounces, we get 1 and 2/16. Changing it to decimal is 1.125. 12 ounces is 12 over 16, or 0.75. And the 11 ounces is 11 over 16 of a pound. That's 0.6875. Now all these decimals added up will give us 2.56 pounds. various ways to do the same calculation. I think I like this one here, the alternative solution 1, the best. Preferably converting everything into ounces completely and divided by 16 to see how many pounds we have. Okay, so 3 questions there for you to try. Moving on to example 2. The cab of Arthur's semi-trailer truck weighs 8.7 tons and the trailer weighs 6.4 tons. If the loaded gross weight of the truck is 21.3 tons, what is the weight of the load that it's carrying? Well, his semi-trailer truck in total is going to have to be 8.7 plus the 6.4. And we can minus that from the 21.3. So that's what they're doing down here. As you can see, they're adding the weight of the cab and the weight of the trailer together. Now when it's fully loaded, it's 21.3, and if we subtract the load of the empty truck, we get an answer of 6.2 tons for the load. So that's 6.2 tons. And they want the answer here in part B, they want the answer in pounds. So we can take our 6.2 tons and multiply it by 2,000 pounds for every ton. Notice here, tons cancels. And doing this calculation, we get the following answer. 12,400 pounds. Okay, so knowing these two ratios up here, where is it, at the top here, make sure you know on page 183 these two ratios because you'll be using them, and you can do questions 1, 2, and 3 here, and then on to the next set as well, 4, 5, and 6. And you can do these in class tomorrow, and I'll go on now on to example 5. Sorry, example 3, pardon me. Now here it's saying that 12-ounce can of vegetables costs $1.49. A 1 pound 2-ounce can of the same vegetables costs $2.19. Which is the better buy? So how do we organize this? We really want to know the cost per ounce. Would be a reasonable way to look at the unit pricing and see which is a better buy. So taking the first one, we have the 12-ounce can of vegetables, and it's costing $1.49. So we can put dollars over ounces like this, okay, and we calculate that, and we can see that when we get our answer for this, it's 0.1242 per ounce, or 1 ounce is this. Okay, so I would just keep this ratio here of 1.49 over 12 ounces. Dividing by 12 will give you the answer of 0.1242 dollars per 1 ounce, per ounce. Going on to the other one, we know that 1 pound 2 ounce costs $2.19. Converting completely to ounces, we've got 18 ounces. So again, the price is $2.19 per 18 ounces. Doing that division, you get 0.1217 dollars per ounce. So the better buy seems to be the second can. Okay, the 1 pound 2 ounce can is a better buy, which is typical. The larger the amount you buy, the better deal it typically is. Okay, so in class tomorrow, I'd like you also to do, if you have time, questions 7, 8, and 9. We'll leave the rest till next day.